Hello and welcome back, critical thinkers. Today's TEK is G4C, which is to verify that a conjecture is false using a counterexample. Now, today's video deals with comparing and contrasting inductive and deductive reasoning. So before we get to counterexamples, it's important for us to understand just what is inductive reasoning and deductive reasoning. So our learning objective for today in this video is to describe inductive and deductive reasoning. Now, you will know you have mastered this objective when you can actually explain to someone what inductive reasoning is and deductive reasoning is, and give them examples of each. Every skill you learn in this video is really important, and it will make you a stronger thinker and a stronger problem solver. Now, I know you can do this, so let's turn your practice into superpower. This section begins with a bunch of definitions, and these definitions are important. I don't need for you to remember the definition word for word, but I do need for you to understand the essence of what those phrases or words mean. So the first phrase that we're going to look at is this thing called inductive reasoning. Now, inductive reasoning can be defined formally as a thought process that uses a number of real examples to arrive at a reasonable prediction, okay? Reasonable prediction. Now, something that comes under inductive reasoning is this thing called conjecture. And so I wanted to give you a feel for what conjecture means, because you're going to hear a lot about conjecture as you move through geometry. Conjecture is a statement that you believe is true based on observing patterns or looking at specific examples. Now, it may be true or it may not be true, but you're making a conclusion based on patterns that you have seen or specific examples that you have been given. Deductive reasoning, right here, is a system of thinking that uses facts, rules, definitions, or properties to reach logical conclusions. Again, I want you to hear what it uses. It uses facts, it uses rules, it uses definitions, and it uses properties. And why? Because we are going to reach what we call a logical conclusion. Okay? I thought it might be helpful if I typed up the compare and contrast section of what inductive and deductive reasoning is. So if we look right here, you can see on the left side we have inductive reasoning, on the right side we have deductive. Now, inductive reasoning right here is when you look at specific examples and you notice patterns, and then you make a general conclusion, a conjecture, just like what we talked about previously. However, a deductive reasoning over on this side, deductive reasoning is when you start with accepted facts, definitions, theorems, and you apply logical steps to prove a conclusion. An example of inductive reasoning would look like this. You measure the angles of 5 different triangles. So you get your protractor out and you measure all 3 angles. Each time you notice that the sum is 180 degrees. So if you added angle 1 plus angle 2 plus angle 3 together, you would get 180. So therefore, you conclude that the sum of the angles in any triangle has to be 180 degrees. So you looked at specific examples, you looked at patterns, and then now you're making a conjecture, a conclusion that says, well, then all triangles must have the sum of 180 degrees when you add all the angles together. For deductive reasoning, a little bit different, okay? So you know that if a square has 4 right angles, you are told that quadrilateral ABCD is a square, then you can deduce, or you can logically think through that because it's a square and because you know that a square has 4 right angles, that this particular square ABCD, it has to have 4 right angles. Do you see the difference between the inductive example and the deductive example? Inductive, you're looking at pattern or specific examples, and then deductive, you're looking at a rule, and then you're given a situation and you're applying that rule to the situation and coming up with a logical conclusion. Okay? Inductive reasoning right here can be powerful, but it's not always 100% certain, okay? Sometimes the patterns may break, okay? For deductive reasoning gives conclusions that are certain as long as you have logically thought through. So what we're going to end up doing is we're going to be doing a lot of deductive stuff. We're going to be looking at theorems, we're going to be looking at postulates, we're going to be looking at definitions, and we're going to logically think our way through to a new conclusion, okay? In inductive reasoning, it is based on patterns and observations. It leads to a conjecture, and an example would be the first 5 even numbers are divisible by 2. So therefore, all even numbers must be divisible by 2. So I gave you another example right here. Let's look at deductive reasoning. Deductive reasoning is based on facts, rules, definitions, theorems, properties, and we take those and it leads us to another conclusion. But this conclusion comes from the facts, rules, definitions, and theorems. It leads to a proof, and it's always true, unlike inductive reasoning, which it may or may not be true. So deductive reasoning is always true if your logic or reasoning is correct. So an example would be all even numbers are divisible by 2. We say that 8 is an even number, so then our conclusion would be 8 has to be divisible by 2. So this is another example. I've tried to give you examples of deductive reasoning and examples of inductive reasoning, okay? So if we look at this, my last little piece of the table says inductive reasoning is like being a detective, and what you're doing is you're looking for patterns. For example, if I said A, E, I, O, what would be the next in this pattern? A, E, I, O. What? Oh, those are vowels, so it would have to be A, E, I, O, U. U. So U would be it. So what we did was we looked at the pattern. We said that they were vowels. The missing vowel would be U. Okay? Deductive reasoning, you're like a lawyer. Okay? Deductive reasoning is like being a lawyer, and you're proving a case because of the facts that you have accumulated. Okay? Inductive reasoning helps us see possibilities. Deductive reasoning helps us prove truths. I'm trying to hit what inductive reasoning is and deductive reasoning is from all different angles. Together, this makes us stronger, okay? I want you to understand that the whole process of geometry is to become a stronger and a better thinker. And so what inductive reasoning is and deductive reasoning is, there are two different ways to approach something. One is looking at patterns, the other is looking at facts, definitions, properties, theorems. It's looking at all of that, and then it's coming up with conclusions. I thought this was pretty cool because I want you to really understand the importance of this. So, why is inductive and deductive reasoning important for sophomores, for people who are taking geometry, for people who are alive? Number one, it builds problem-solving skills. In math, you need to be able to spot patterns, which is inductive reasoning, and you also need to be able to prove results, which is deductive reasoning. And both skills are tested in geometry, algebra, and in the sciences, okay? 2, it strengthens critical thinking skills, okay? Geometry isn't just about shapes. It's about learning how to think logically. Think logically. Inductive reasoning teaches us how to make good guesses by looking at patterns. Deductive reasoning teaches us how to prove when something is always going to be true. Okay? And thirdly, It prepares for real life situations. So inductive reasoning may look like this. It helps us make better predictions. Every time I study like an extra hour, I notice that I do better on tests. So maybe I should just keep that up. It's like I know I've done better, so when I study extra, I get better grades. So therefore, I'm going to continue to study that extra time to get those better grades. Deductive reasoning helps us make solid, smart choices. If I don't turn in assignments, I can't pass. Therefore, I didn't turn in 2 assignments, so my grade is going to drop. In government, I did not complete the second chapter questions, so my grade is going to reflect that. So that is deductive reasoning, okay? If we also look as to why it's important for everybody else in this world, in daily life, we use inductive reasoning all the time. Every time I leave 20 minutes late, I hit Dallas traffic. I'll probably hit traffic again if I leave 20 minutes late today. We all use deductive reasoning. Here we go. If the store closes at 8 and it's now 7:45, then I don't have time to go in and get a lot of groceries. So deductive reasoning versus inductive. Deductive versus inductive. Now, who uses this? Careers and in citizenship. Scientists use induction or inductive reasoning to spot trends in data. So they'll be looking at graphs, they'll be looking at information they get from testing certain things, and then they use deductive reasoning to prove certain scientific laws. Lawyers use deductive reasoning to apply laws to cases all the time. Business people use inductive reasoning to notice customer habits, and they use deductive reasoning to plan strategies on how to use those habits in the best interest of the company. Voters and citizens use both inductive reasoning and deductive reasoning to evaluate evidence, to look at promises that have been made to us, and then to look at arguments, okay? Because you need both. You need inductive and deductive reasoning. We also use inductive and deductive reasoning to avoid mistakes. Inductive reasoning, sometimes it can trick us just by looking at patterns, because sometimes patterns don't continue through. Sometimes the pattern breaks. Deductive reasoning alone can seem real rigid if we don't notice that the new evidence that's around us. So we need both inductive and deductive to make wise decisions for ourselves, for our loved ones, and for our world. Now it's your turn to take the lead. Let's see how you can apply what we've just learned with inductive and deductive reasoning to solve these problems. So in part A, we have inductive reasoning using patterns and conjectures. In part B, we have deductive reasoning using facts and proofs. So I'm just going to quickly read through the problems. It says, the first 4 numbers in a sequence are 3, 6, 9, and 12. What's the next number? State the pattern and make a conjecture about the sequence. Number 2, you measure the angles of 4 different quadrilaterals. Each time, the sum of those angles is 360 degrees. What conjecture can you make based upon that data? Number 3, a student notices that the diagonals of a square are always perpendicular in every example they draw. What conjecture might that student make about the diagonals of a square? Okay, so now we're going to move to deductive reasoning, and we're going to look at facts and proof. So number 4 is, given all vertical angles are congruent, we know that angle 1 and angle 2 are vertical angles. Now, what can you conclude based upon that information? Number 5, given a polygon has exactly 3 sides, okay, then it's a triangle. Figure ABC has 3 sides. What can you conclude, or what can you tell us about figure ABC? Number 6, given if two lines are parallel, then corresponding angles are congruent. This is given to you. We know that lines M and N are parallel. We're given that A and B, angle A and B, are corresponding angles. What must be true? Okay. Now, the seventh question is a bit challenging, but you can do this. A student looks at these sums. So 1 plus 3 equals 4. 1 plus 3 plus 5 equals 9. 1 plus 3 plus 5 plus 7 equals 16. 1 plus 3 plus 5 plus 7 plus 9 equals 25. Then they say the sum of the first n odd numbers is always a perfect square. Is this inductive reasoning or is it deductive reasoning, and why? So I need for you to do this. I want you to copy each of the questions down in your notebook, and then I want you to answer these 7 in your notebook. Okay? If you have any questions or issues, please ask for help. You may check your answers on the next slide. And now please pause the video and complete your work. When you're finished, press play to continue. My friends, here are the answers to the problems. Please pause the video now and check your answers. When you're finished, press play to continue. This is it for today's video. We did some really good work today. If something doesn't make sense to you, that is your cue to ask questions. In fact, it's your responsibility to ask questions. Now, you can come talk to me, you can talk with your classmates, your shoulder partners, or even try AI for a step-by-step explanation. Please remember that we're a team here, and we're all here to help one another succeed. Now, you learn best by breaking complex concepts down into smaller, more manageable skills. And that's exactly what we did in our video today. You are turning your practice into your superpower. Now, I believe in you, and I know that you can do this. You are working your way to success one skill at a time. I want you to have a great day, and thank you for working with me.